Good afternoon, class. Here's College Algebra Practice Test number 4, Module 4, covering Chapter 7 and 8. Review, here's Chapter 8, Analytic Geometry. We are going to cover Chapter 8, Analytic Geometry. Find an equation of the circle with its center at 1, -2 and radius 2, graph the circle. So let's go over the synopsis of the concept first. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. That's a definition. So if it's centered at 0, 0, the origin, the equation is x squared plus y squared equals r squared. If it's centered at a different location, such as h, k, and it's x minus h quantity squared plus y minus k quantity squared equals r squared. And it comes from the formula that you can see here, x squared plus y squared equals r squared, Pythagorean theorem. Same thing here, x minus h and y minus k are the distance formulas, and then this will give you the result. So we write the synopsis of it here and remind everybody that the area is pi r squared, circumference is 2 pi r. So with that being the case, the radius is 2, the center is located at 1, -2. So according to this formula, x minus h or 1 quantity squared plus y minus -2 means y plus 2 quantity squared equals r squared, which is 4. So we throw in the center, which is located at 1, -2. Then basically we are going to go back to the center and use our units up and down, left and right. So if we go 2 units left and right, so this has coordinates 1 and -2. Then we're going to have -1, -2, and +3, -2, because basically this number, you add our units and you subtract from. Going back to the center, up and down by 2 units. So the y coordinate, you add 2 units, you subtract 2 units. You have those pairs, putting them together. That gives us the graph. Write the equation of a circle in standard form, identify the center and the radius. So we remember the formulas here, and we're going to use completing the square by putting x squared and minus 4x together, y squared and 10y together, moving the -7 to the right, making it +7. So what do we need here? B is -4, reminding you of the concept. This is B. When you divide it by 2, you get -2. And if you square that, you get +4. So you need to add 4 here. Over here, 10 divided by 2, 5 squared is 25. So we add 4 to both sides, 25 to both sides. This becomes x minus 2 quantity squared. This becomes y plus 5 quantity squared. We add up the right side to 36. Therefore, the radius is 6 and the center is located as +2, -5. So we come up with the center 2, -5. So we have to go R units, 6 units to the left and right, 6 units up and down. So add 6, you get 8, subtract 6, you get -4. These are the two pairs. Now you do that to the y coordinate, add 6 units and subtract 6 units, you get those two pairs. And now putting them together gives us the graph of a circle. Graph the ellipse by finding its center and vertices. X squared over 25 plus y squared over 16 equals 1. So let's look at the definition. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F sub 1 and F sub 2 represent the two foci of an ellipse. P of 1 plus P of 2 equals 2a. So let's look at this graph to make some sense out of this. So when it's centered at 0, 0, okay, if you pick, and it doesn't have to be centered at 0, 0, if you pick any point and connect them to focus 1, focus 2, their sum is constant and is 2 times a. This distance is a, this distance is b. So a comma 0, negative a comma 0, 0 b, 0 negative b. So we have the basic centered at 0, 0, it's x squared over a squared plus y squared over b squared equals 1. If the center is located at h comma k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. The area is pi ab, and the relationship is such that b squared plus c squared equals a squared. This distance is c. This distance is a, this distance b. The only thing I want to mention that if it happened to be elongated along the y-axis, in other words, it could be that b is larger than a. In that case, b squared and a squared, they change places, and we want to be very careful with that. All right. This one is centered at 0, 0 clearly. A is square root of 25, b is square root of 4, according to this formula. Because a is larger than b, the vertices are located at 5, 0, negative 5, 0. This is it. 5, 0, negative 5, 0. The other ones are called co-vertices because b is 4, 0, negative 4, 0, positive 4. And now again, put them together. And that's your basic shape. And F1 is somewhere here, F2 is somewhere here, and we can find the value of C, the distance from this, using B squared plus C squared equals A squared if need be. Identify the coordinates of the center, the vertices, the co-vertices, and foci. Graph the ellipse. So when we compare these two, it is centered at -5, +7. A is 2 square root of 4. B is square root of 9, 3. So according to this formula, just all you have to compare. Now, which one is larger? B. So the vertices would be B units up, B units down from the center. Again, because B is larger than A, it's elongated along the y-axis. So to this 7, you add 3, and from it you subtract 3. So those are the, so that is the center. minus 5, 7. And as I mentioned, B units up and down, those are the vertices. Co-vertices, A units, 2 units, left and right. So to this number negative 5, you are going to add 2 and then subtract 2. So subtract, you get minus 7, add, you get minus 3. So those are the co-vertices. So right here, we have the graph. Okay, everybody, we have the graph. Let's add foci since they ask. And generally speaking, you know, you are following Pythagorean identity and you put the smaller one next to each other. And it is important to understand that it's either a squared plus c squared equals b squared or b squared plus c squared equals a squared. Why do we have two different formulas? It depends whether a is larger or b is larger. Since b is larger, I'm going to use this one. So a squared plus c squared equals b squared. Let's write it down. Two squared plus c squared is equal to 3 squared. So c squared equals 5 and c becomes square root of 5. So go back to the center. And because it's elongated along the y-axis, because b is larger than a, so the foci are somewhere here and here. From the center, you go c units up, c units down, those are the foci. So minus 5, and then 2, 7, you add and subtract this number. And to have a better understanding now, we're going to roughly change it to a decimal representation, 4.77, and we get those numbers. Okay, because square root of 5 is 2 point something. So 7 minus square root of 5 is about 4.77, maybe 4.8. It's about 9.2, and that's the graph. So those are F1, F2. They may not be to scale, but close enough. Now the graph is given. Use the graph of the ellipse to determine the equation in standard format. So we are going to, first and foremost, locate what we can. So we are going to write which formula, this one or this one. Obviously, this formula. The center is right here, which has location -2, 2. So right here we have x minus -2 or x plus 2, and this one here we have y minus 2. We have it now. We're going to go with a and b to find those. We notice it's elongated along the y-axis, so the vertices are those 2 points, and the coordinates, we read them as -2, 5, -2, -1. So this distance from 2 to 5, or this distance from -1 to 2, and you should check both. They are identical, and so b becomes 3, and this distance, a, is 2. So we have the co-vertices, we have the vertices, we have this distance a equals 2, this distance b equals 3, and now we replace those two values also. So a squared makes it 4, b squared makes it 9, and that's the final equation. Give the equation of the asymptotes and graph the hyperbolas. One of them is x squared over 16 minus y squared over 25 equals 1. The other one is y squared over 25 minus x squared over 16 equals 1. There is a reason that I have both of them, given at the same time, because I want to compare and contrast. So this is the general shape of a hyperbola. Okay, x squared over a squared minus y squared over b squared equals 1. Y squared over b squared minus x squared over a squared equals 1. What I like to do is to keep the a squared under a squared in both cases. When you do that, the equation of asymptotes do not change. In some texts, they do plus minus b over a times x if it's centered at 0, 0. Okay. And the relationship is that a squared plus b squared equals c squared. First of all, this distance is c, and it's always larger than a, which is this distance. This distance is a, this distance is b. Okay. And it's always larger than that. By the way, this point has coordinates a, b, a minus b, minus ab, minus a minus b. That gives rise to this fundamental rectangle. So a hyperbola is a set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. So in this case now, pf1 minus pf2 is a constant of 2 times a. Remember, this is the distance a in this case. So what's happening is, in both cases, when I write it in this format, a is 4 and b is 5. A is the square root of 16, b is the square root of 25, and the center in both cases is 0, 0. So far, everything is identical. So a is 4, b is 5, center at 0, 0. And the asymptotes plus minus b over a, plus minus b over a times x. So plus minus 5 over 4 times x. So those are the same now. We'll discuss the differences in a moment. So we have first the asymptotes. In order to graph the asymptotes, you can graph the line y equals 5 over 4x. I can write next to that, which is really this one. And y, let me just write. So this as the equation y equals 5 over 4x, whereas this one has the equation y equals minus 5 over 4x. Okay. And you can always use a fundamental, rectangle to see the graph. Okay, just for the sake of argument, those points, and you connect them, they give you that. Fundamental rectangle. The purpose of that is to actually help you draw the asymptotes. And so now for this one, the vertices are located at 4, 0, minus 4, 0. And that's the graph. And these are changed to dash lines because asymptotes are not part of the graph. They help us with the graph. They are not part of the graph. So, but for this one, now the vertices are located at 0, 5, 0, negative 5. So everything is the same, except now they open up and down. So this opens sideways, this opens up and down. And you want to distinguish between the two. Identify the coordinates of the center, the vertices, foci, and the equation of asymptotes, graph the hyperbola. So obviously, this one, we compare it to one of these two. And we better compare it with this one because x minus h quantity squared is having a positive value, right? This has a negative value in front of it. I mean, the coefficient if you will. And so the center is located at 1, 2. A equals square root of 9 over 3. B is square root of 16 over 4. That's just a matter of comparison to this one. As far as the asymptotes are concerned, I hope you remember the asymptotes were y equals plus minus b over a times x. Now, if the location is changed for the center, it changes the location of the asymptotes in the same manner. So y minus k plus minus b over a x minus h. So according to this formula, y minus 2 plus minus b over a x minus 1. So in short, whatever this one is comes to the left, whatever this one is comes to the right without the exponents. That's one easy way to look at it. And so I can move the -2. And if I work on this by distributing, for example, for the 4/3, positive 4/3, just a positive 4/3, I get 4/3 x minus 4/3 plus 2, which gives me 2/3. This is one of them. You can find the other one in the same manner. I can quickly show you. So if I go with, so this was for the positive, for the negative, y equals minus 4/3 x minus 1 plus 2. So I get minus 4/3 x, then plus 4/3 and 2 plus 10/3. This is the second one. So for one of them, for example, for this one, if I want to graph this, obviously this is my y-intercept, meaning 0, 2/3. If I want the x-intercept, if I set this one equal to 0, x becomes -1/2. So I have those pairs, and right away I can graph those. The same thing, I can use pairs properly for those and graph them. So this is the second one. And clearly, this is your y-intercept, meaning 0, 10/3. And then if you set this one equal to 0, minus 4x equals 10, or x equals 5/2, you can graph this. This is what I came up with here. And now, those are the graphs. Just pick up a couple of pairs, graph them, and you're done with the asymptotes. Now, let's put the center in 1, 2, and then 3 units to the right and left of the center. The center is 1, 2. We're going to go a units to the right and left. And then vertices have those coordinates, -2, 2, 4, 2, right? So basically, those are your graphs, those two halves. Since a squared plus b squared equals c squared, we can find the foci. So we are following the center, the vertices. Now we are looking for that. And c becomes 5 because this is a squared and b squared. 9 and 16 is 25. So you can write it if you want here. 3 squared or squared equals c squared. 25 equals c squared. C becomes 5. So from the center, we're going to go 5 units, C units to the right, to the left. And those are foci. Okay. Put them together and graph them. Now you really have to change the two asymptotes into dashed lines. Use a graph to determine its equation in standard form. Well, clearly I can draw the asymptotes here. And here's the center. We want to find A and B. And so since it opens up and down, okay, we are looking for this distance and this distance. From this point to this point and this point to this point, clearly there are 3 units. So B units up and down, vertices are located at -1, 3, and -1, -3. Therefore, B must be 3. Right? Now, C units up and down is the foci. So this distance or this distance all the way to the green point, okay, is 3 squared of 2. Therefore, C is 3 squared of 2. We know A squared plus B squared is C squared. So A squared plus B squared, 3 squared, or 3 squared of 2 squared. So this is 9. This is 9 times 2, 18, which makes A squared equals 9. And A becomes 3. So now, going back to this formula, okay, why this formula? Because it opens up and down. Y minus K squared, K is 0, so Y minus 0 is squared, or simply Y squared over B squared over 9 minus X minus H. X minus -1 makes it X plus 1 quantity squared over A squared, which we found it to be 3 squared, or 9 equals 1. Well, as far as the asymptotes are concerned, Y minus K is plus minus B over 8 X minus H. Plus minus X plus 1, because those cancel each other. Remember, B and A are identical. So it becomes 1, simply Y equals X plus 1, Y equals minus X minus 1. This means 2 equations, everybody. This means 2 equations. 2 equations. And as always, when you draw the asymptotes, they must be dashed lines. A parabola is defined as follows. A parabola is the collection of all points P in the plane that are the same distance d from a fixed point F as they are from a fixed line D. The point F is called the focus of the parabola and the line D is its directrix. As a result, the parabola is the set of all points P such that D stands for the distance. Distance of F and P is the same as distance of P and D. So the idea is that this is a parabola. If you pick any point and you connect it to its focus and then drop it perpendicular to its directrix, the two distances must be identical. That's how you define a parabola. And I remind you what we learned in algebra, in intermediate algebra, that is y equals ax squared plus bx plus c. If it's centered at h and k, we can write it in this format: a times x minus h quantity squared plus k. This opens up and down depending on the value of a. A is positive, opens up; a is negative, opens down. Or x equals a y squared plus by plus c, or a times y minus k quantity squared plus h. In this case, it opens sideways. This is what we have learned. Now, from analytic geometry, we can put this in a different format. Now, if you want to stick with those formulas, and I find it easier, you can stick with that. All you have to know, if these formulas, you want to compare them, the relationship between A and P, the focal distance, the focus, this distance is 1 over 4A, okay? 1 over 4AP equals 1. 4, that's another way of thinking about it. 4 times A times P is equal to 1. So if you have one of them, you can find the other. So look at the general concept. Again, this may be easier to see. Pick any point connected to the focus and drop it perpendicular to a directrix. These two distances must be identical. This is the axis of symmetry. Now we have a definition for something called lattice rectum. The lattice rectum of a conic section is the chord through a focus parallel to the directrix, which is equal to 4 times the focal distance, 4 times P. So this distance. So there is a line segment, which we call it chord, parallel to this directrix, which goes through the focus. Okay. And so I hope you see that. And by the way, you see this distance A in some courses, they call it F. In some courses, they call it P, which is different than this A. So depending on the text. So in this case, they're using A here. I just want you to understand the concept. Now, this is 2 times the focal distance. I'd rather use F or P. So this is 2 times the focal distance. And by definition is identical to this. And the same thing here, identical to this. And they add up to 2 times 2A or 4A. That's how they come up with that. And we have these formulas: y squared equals 4px if it's centered at 0, 0, y minus k quantity squared is 4p times x minus h. Or x equals a times y minus k squared plus h, a equals 1 over 4p. I wrote one of them as an example so you see how they go when you want to compare something that opens up and down. Remember, when it opens up and down, y is of second degree. Sideways, I mean, y is of second degree, whereas up and down, x is of second degree. All right, identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry and the directrix. Graph the parabola. Okay, let's discuss a couple of things. The moment we see this, the number next to x, sitting next to it, x, if you say it equal to 0, becomes -4, this becomes +2. That's the vertex. And y is of degree 2, it opens to the right. Now, before we continue, just to give you an idea of how it is supposed to look like, because it will help you figure out the equation for the directrix, the focus. You don't have to really memorize them, but let me show you something, and I'm going to erase it in a moment. So the vertex is located at -4, 2, okay, and it opens to the right. So again, by no means this is too skewed. So you expect it to look like this. Why am I drawing this? And again, this may be completely off. I just want to make a point. If it opens that way, I know that okay, and this is the axis of symmetry going through the vertex. I know somewhere here, I don't know the exact location, is the focus. And I know the directrix is some line which is a vertical line, okay? And so this has the equation x equals something. Again, we're going to discuss how we arrive at it in a moment. But we understand the concept. That is extremely important. So all we have to do, if we can find this distance, because remember this distance is called the focal distance, which is P or F. So this P that we are referring to. So if we can find P, basically what happens is this. This one has coordinates -4, 2. So I'm going to take this point to the right by the focal distance, whatever this number is, which means for the focus, I will have the same y coordinate, then -4 plus P. If it opens this way, it's subtracted from that. As far as this line is concerned, the same x coordinate as the vertex, but you go to the left by focal distance because this distance is also P. So x equals, the equation will be x equals this number minus whatever this focal distance is. The point being, everything depends on the value of P now. All you have to do, figure out what's P. So when we compare, if you want to go with this formula, when we compare this formula to this formula, 4P is 4/5. And P is 1/5 or 0.2. So this one, compare it to this. 4P is 4/5, P is 1/5. So what did I say? For the focus, from the vertex, go P units to the right. So we are going to add 0.2, we get -3.82. Now let me just, that becomes this point. I'm going to clean up the mess in a moment. Axis of symmetry, this line y equals 2. Again, I'm going to clean up my mess. And then the directrix, going back to the vertex, the x coordinate, and then minus P or -4.2. So let me clean up. So the explanation was so we can easily have an idea how the graph is supposed to look like, and may not be scared. And the lattice rectum, you remember, is this distance, which is equal to 4P. The lattice rectum of the conic is the chord through the focus parallel to the conic section directrix, and it's equal to 4 times P. We already know 4 times P is 4/5. We had it here, or 0.8. Use the graph of the parabola to determine its equation in standard form. Well, we know x squared equals 4py, or x minus h squared is minus 4py minus k. I really don't want to stick with those formulas, but I will do that. I think I find it easier if we go what we know from the past. But this is the case where the uh, parabola opens up or down, and obviously we know it opens down, so that's why we go with minus 4p. I just wanted to remind you. So y squared is 4px or minus 4px. It depends if it opens, in this case, to the right, or in this case, to the left. X squared occurs 4py, okay, opens up. X squared occurs minus 4py, opens down. So let's look at the vertex clearly located at negative 3, 5, with the focus located at negative 3, 319, 64. So this is, we just read that from the graph. This distance is the focal distance, or P. So we look at these two distances. So 5 minus 319, 64, this is the P. Let me just show you this distance. Is the P. So 5 minus 319, 64. So 5 times 64 minus 319 gives you 1 over 64. It's pretty small. So if we want to continue on that thoughts, we're going to go with the formula here. X plus 3 quantity squared minus 4p y minus 5. These two give us negative 1 over 60. However, if I go back to the intermediate algebra, all I have to do, just stick with this formula. I think it's a lot easier. So take a look, see how we approach that. We know when it opens up or down, this is how we deal with that. So we are going to plug in the vertex. So x minus negative 3 makes it x plus 3 quantity squared plus k, or plus 5. And we've already, so in other words, we write this, we write this, we write this, then we go here. So because I need this value. And a is 1 over minus 4p. Which makes it negative 16. So I'm going to replace the a, and I'm done. I think it's a tad faster if we go this route. By the way, the focal distance is considered to be positive always, and then you have to account for negativity if it opens to the left or down, for the sake of the formula. Given the function, express it in standard form, f of x equals a times x minus h quantity squared plus k, and find the x-intercept, the y-intercept, the vertex, find the axis of symmetry, and graph the function. So the information that you've seen before from previous courses. So what do we do? First of all, we put these two together and we take the two out. Secondly, we need to, inside, we need to add something that makes it a perfect square. B is 2. This is B. Divided by 2 is 1. Squared is 1. So we need to add 1 here. When we add 1 here, that means we have added 2. We have to subtract that. So please understand, adding 1 inside the parentheses because there is a multiplier outside. It is the product of the two that you're adding. So either you say you're going to subtract at the same side, or you can add positive 2 to both sides. So that means plus 2 here. But it's one side and it will do the job. So this becomes 2 times x plus 1 squared. This becomes plus 4. And obviously the vertex becomes negative 1 comma 4. And it opens up because a is positive. So the vertex is located at negative 1, 4, and it opens up. Just that tells us there is no x-intercept. The y-intercept, x is 0, becomes 0, 6. So that's the vertex. X-intercept, there is none. Y-intercept, 0, 6. By the way, as far as the x-intercept is concerned, remember, I'm going to give you another approach. X-intercept means y equals 0. Means 2x squared plus 4x plus 6 equals 0. And if you calculate this, I'll leave it for you, p squared minus 4ac is negative. That means there is no real solutions. All right, and so by symmetry, if 0, 6, okay, so this is x equals negative 1, right? So by symmetry, if this is the point, there is another point here, minus 2, 6. So how do you find that? Just the same, you see this distance, you go the same distance, and you find this point. So perhaps you can put the point first and then figure out. So why is it negative 2, 6? Remember, this distance is 1, right? How do we know this distance is 1? Because the vertex is located at negative 1, 4. So this distance is 1. So you go 1 more, this distance now must be 2. So minus 2, 6. And we know it opens up, so it looks like that. Very straightforward. Identify the graph of each equation. Obviously, these are conic sections and we can put them in standard form to figure them out. But if you want to figure out what the answer is pretty fast, if you look at this, for example, you see the coefficient of x squared and y squared are identical. So it becomes a circle. Okay, look. They have the same x squared and y squared, they have the same coefficient. So if we have x squared and y squared, and they both have the same coefficient, identical, it's a circle. This one has 9, this one has 1. They have, so this would be identical. This would be same sign. This one when they are on the same side, they have different signs. That's a hyperbola. So a quick recap. Identical coefficients for x squared and y squared is a circle. Same sign, but not identical. Ellipse. Bring them to the same side. They have different signs. One is positive, one is negative. It's a hyperbola. Now, if one of them is of degree 1 and the other one is of degree 2, that means either x is degree 1 or y and vice versa. And by the way, h of x means y. If x is degree 2, it opens up and down. So this up and down, this opens sideways. So this one, the first one, it opens down because a is -2, it's negative, and we have x squared. This one opens up because a is 1, right? A is 1 here, which is positive, and we have x squared. This one opens to the right because a is 1, this is 1, and we have y squared. So it's quadratic with respect to y. That's the reason.